we have an equation ataupun formula to describe this effect of temperature on reaction kinetics, and it is known as Arrhenius equation. Okay, right. In this Arrhenius equation, we have rate constant, we have EA, we also have temperature and pre-exponential factor. Okay, so we have these parameters in Arrhenius equation. Okay, right. So for this one also, you may need to consider for, you may need to prepare atau plot graph. Okay, ada lagi satu graph that you will be learning later on. Okay, and then we are done. Dah tak ada graph dah. Okay, alright. So this will be the two last formulas in topic 1. Okay, moving on. Arrhenius equation. So Arrhenius found that in most reaction, the increase in rate with increasing temperature is exponential. Okay, exponential ni maksudnya dia bukan straight line. Kalau straight line tu dia berkadar langsung kan. Exponential ni dia graph dia increasing but graph dia tu curve. Okay? So reaction rate obey 3 factors. 1, okay, so we are talking about reaction rate, okay guys? Okay, reaction rate obey 3 factors. 1 is the fraction of molecule possessing an energy of EA or greater. And secondly, the number of collision occurring per second. Thirdly, we have the fraction of collision that have the appropriate orientation. So we are already familiar with this number 1 and number 3. Okay, because we have the same factors in effective collision. Remember, effective collision, okay, the particles need to possess sufficient energy in order to overcome the EA, sufficient energy or greater energy in order to overcome the EA. And then secondly, the collision need to take place in appropriate orientation. But we are talking about reaction rate, guys. Okay, so dia overlap sikit. The rules can be overlap. So kita ada tambahan sikit the number of collision occurring per second. Because rate guys is always has something to do with time. Okay, has something to do with time. So maksudnya the rate is also depends on the collision occurring per second, per time lah. Okay, so when more collision occurring per time, that means the reaction rate will be higher. Okay, it will be higher. So kalau ini just effective collision, so dia tak concern on the per time tu, dia tak concern on per second tu, but reaction rate is related ataupun is directly related ataupun closely related to the number of collision per time. Okay, so we have an additional information that you have to be aware of related to reaction rate. So these 3 must be obeyed. Okay, so luckily dia overlap dengan effective collision. So boleh hafal sekali terus. Dan kalau dia ask for 3 factors, that means you have to include this one. Kalau dia tanya 2 factors, include sajalah these 2 because this is the one that is most common because we have these 2 in effective collision as well. The factors that can affect the effective collision. Okay, so therefore the 3 factors are incorporated in Arrhenius equation. So we incorporate these 3 in Arrhenius equation. Kita take into consideration of these 3 factors and then we place it in Arrhenius equation. Okay, alright. So Arrhenius equation quantitatively describe the relationship between the rate constant K, temperature, and the activation energy. This is how the Arrhenius equation looks like. So this is the rate constant. This is what we call pre-exponential factor. Okay, so each reaction has its own pre-exponential factor. Okay, and then this is the exponent. Okay, kuasa ya ni dia sebenarnya begini. Kuasa EA over RT. Yeah, macam tu. Kuasa negatif EA over RT. Okay, alright. So temperature must be converted into Kelvin, guys. Activation must be in J mole negative 1. Kenapa dia mesti in J bukan in KJ? Because dia nak tally kan with R. The unit of R. Okay, so this is something that you need to look into. I mean, you have to be careful. Okay, sometimes the unit of activation energy is given in terms of kJ. So you kena tukar into J first. Because why? See, dia kena tally lah. Okay, because the unit of gas constant used for this formula is J K negative 1 mole negative 1. And then look at the value of the constant. It's 8.314, not 0.0820621. 0.0821 ataupun 0.08206. Okay, alright. Remember yang ini yang kalau kita belajar gas law, ideal gas last time, ATM, liter, yang ada K, and what else? ATM, liter, K, PV, NRT, mole. Okay, PV and so PV R, so PV and RT. So PV and T. Okay, is equal to R. So P negative PL K negative 1 mole negative 1. Okay, so this is the unit. So as you can see, we don't have pressure, we don't have mole in this formula. So that is why we don't use this value. Do not use this value, guys. You must use this value, 8.31. Okay, because this value is related, dia ada kena-mengena with kinetic energy, because in joule, right? So energy in joule. Okay, that's why we need to use this value, not this one. Okay, not this one. Okay, guys. Okay, so 8.314 JK negative 1 mole negative 1. Oh, we do have mole negative 1 there. We do have mole in the unit of rate constant. In the unit of R. Okay, gas constant. Okay, right, so this is the formula of Arrhenius equation. Okay, the activation energy and the pre-exponential factor, which is A, can be determined by measuring the rate constant for a reaction at different temperature. Okay, so basically we have K is equal to AE right? So the question can ask you to find K. Okay, the question can ask you to find K, can ask you to find EA, can ask you to find temperature, and even the pre-exponential factor. No, R lah, R is constant kan after all. So the question can ask you to find any of these variables in the Arrhenius equation. Okay, alright, so from the Arrhenius equation, the larger the EA, the fewer molecules that have sufficient energy to overcome the energy barrier. Okay, so we knew this already. Kita dah tahu based on energy profile diagram. Okay, the higher the EA, that means more molecule will require more energy to overcome the EA. So it will be difficult to overcome the EA kan. Kalau tinggi EA tu, that means susah nak overcome. Therefore, the effective collision will also be reduced. Okay, but this is supported. Okay, this statement is also supported by Arrhenius equation. Cuba tengok this one. Sebab dia kuasa sikit kan, jadi dia macam susah sikit lah nak ni. Tapi you must be able to determine that. Okay, E kuasa negative EA over RT. And then K. K is equal to AE EA RT. And then you kuasa kan, and then dah lah exponent, and then you kuasa kan, kuasa dia negatif dekat situ. So it will give negative impact to K sebenarnya, mathematically supported. Okay, bukan teori saja. So we have this equation to support that statement. Okay, mathematically. So, you yang pandai matematik tu, yang you lagi pandai daripada saya kan, you mesti tahu kalau dia ni kuasa negatif EA kan. So, what will happen to this value? Okay, if this EA is larger, imagine if this EA is larger, what happened to the K? Will the K become reduced atau will the K become higher? Okay, sepatutnya if the EA punya value is higher, the K value should be reduced. Try lah, cuba try. Masukkan value, compare. Okay? Okay. Thus, okay, so when we have the larger EA, that means fewer molecules that have sufficient energy to overcome the energy barrier. Therefore, what happened to the rate constant? The rate constant will be smaller. Okay? Alright, so we can conclude that when we have higher temperature, that means the value of K will increase. We will have larger K value. Sebab apa? T is directly proportional to rate kan? When T increases, rate will also increases. And rate is also directly proportional to K. Kan? So when we have larger K, that means the rate increases. And vice versa lah, and terbalik lah. Kalau lower T, that means lower K, the rate decrease. Okay? Alright, moving on. Okay, so we have two versions of Arrhenius equation sebenarnya. So we have this one, and the other one is this alternative form of Arrhenius equation. Okay, so this is in terms of exponential relationship. If we were to draw a graph based on this one, we will get curve dekat situ. Kita akan dapat curve. Rate constant versus temperature, we will get a curve. Okay, alright. Normally, yelah curve. Curve kan. Kita, the information yang kita boleh extract tu not much. Banyak, tapi dia sebab curve, dia punya slope tu will be, we need to draw a tangent and then we have different value of slope dekat situ kan. So, dia tedious sikit lah dekat situ. Okay, alright. So, we can transform this in terms of linear form. Boleh transform this in terms of linear form. So, kita buat macam mana nak transform into linear form of this equation? Kita lonkan kiri dan kanan. Okay, kita lonkan K ni dan lonkan this whole thing and then we rearrange everything so that we can get this straight line equation. Kita tallykan dia with the straight line equation. So we get ln K is equal to negative EA over R times 1 over T plus ln A. When we equate this equation of Arrhenius to the straight line equation, we get ln K as Y. So EA over R as the slope or the M. 1 over T will be the X. Then ln A is the intercept. Okay, if we were to transform the information given to us into a straight line graph. Okay, kita nak transform, dapatkan straight line graph. That means you have to make sure that your value should be in ln K for your y-axis. Dia akan bagi begini dia akan bagi you K kalau you kena buat graph. Data dia log K dengan T. Dia bagi K dengan T. So dia nak you draw a straight line graph. So how do you draw this straight line graph? Okay, that means you kena prepare this ln K and also 1 over T versus 1 over T like this. See? Then you dapat straight line. Bila dapat straight line, of course you have to calculate for slope. Betul tak? Confirm kena calculate for slope. So what does slope represent in this case? Okay, remember kita ada banyak sangat graph, so jangan confuse, you kena tahu, okay, graph ni bila nak kena buat. Yang ni bila nak kena buat. Okay, this integrated rate law, what is the axis? Okay, last time, concentration versus time. That one, the slope, kita nak cari apa? Okay, the rate. Remember last time, yang awal-awal tu. So make sure that you know how to differentiate those graph. Okay, nanti pening. Alright, so when you have a straight line, definitely you will need to calculate the slope. Okay, and then the slope actually represent the EA over R negative. Okay, based on this equation. Negative EA over R. The value of slope is equal to this whole thing. So you can find out the EA. Okay, when you transfer the R and the negative to the other side. Okay, alright. Inilah kalau ini enhanced view of the graph just now, ln K versus 1 over T. So this is the formula that we will be using. Okay, so ln K is the Y, this is M, X plus C. Okay, so this EAR with the negative sign represent the slope. Okay, cuba tengok contoh. Like I said just now, okay, the question can ask you to prepare a graph ataupun to plot a graph. Okay, the rate you for this question, you will be asked to determine the activation energy. Okay, let's look at the question first. Look at the question. The rate constant for the decomposition of dinitrogen peroxide. So this is the equation. Okay, were measured at 5 different temperatures. The data are shown in the table. So you have to plot the ln K versus 1 over T and determine the activation energy in kJ per mole. So it is mentioned, the unit is mentioned in the question. Make sure that you convert, lastly, you have to convert into kJ per mole for the reaction. Okay, so we have 5 experiments here. And the data given to us is in terms of K and temperature. Okay, alright, so you must be aware, you mesti kena tahulah that you need this value, you need to transform this value into, that means you have to prepare 2 more columns. Okay, one is ln K, the other one is 1 over T. Cari the value. You lnkan all the K's and then you 1 over the temperature. Okay, so for your graph, you will be needing this value. You'll be using these two values, these 2 columns to plot your graph. Okay, so yeah, this is the one that I've mentioned to you just now. You can prepare these 2 columns. Okay, alright. So you dah dapat graph. So you buatlah graph. Make sure ada berapa point yang you buat tu. Those should be appeared in your graph, on your graph. Okay, so ln K versus 1 over T. Okay, alright. So from the straight line graph, you can see that it will produce a negative slope. Betul tak? Sebab dia ke bawah, negative slope. Maksudnya value slope you tu, dia boleh predict awal-awal. Maksudnya bila you buat calculation, you dapat positive slope. Salah kira lah somewhere tu. Okay, so ni negative graph. That means you should get negative value of slope. Right. So the slope, definitely you need to calculate the slope. So this is the value of your slope. See, dapat negative. Okay, so the question is asking for EA, guys. So you have to relate the slope is equal to negative EA over R. And this is the value of the slope. So you can see negative, it will be cancelled out. That's why you end up with positive value here, positive value. Okay, alright, so this is in J in Joule. Later on, you have to convert into KJ. Because kenapa in J? Mesti confirm in J dulu. Sebab you punya unit of gas constant is in J. So you memang kena buat dalam J dulu. Then baru you convert into KJ. Okay, katakanlah later on, dia nak cari temperature. EA dia dah bagi. So you have to be careful, EA tu. EA tu, you must make sure that the unit should be in J. Okay? You kena make sure that EA yang dia bagi value tu, sebab you nak kena cari temperature. Ni cerita lain lah, you nak cari temperature ataupun you want to find the rate constant ke kan. So by right, the EA should be given to you. But the EA, the check on the unit. Whether the unit is given in terms of joule or kilojoule. Okay? If not, kalau siapa yang tak pakai unit, definitely tak perasan benda-benda macam ni. So that is why unit is very important. Lagi sekali saya stresskan. Okay? Alright. Okay. So this is the formula that you should know Okay, alright. So this one is for one temperature at a time. Maksudnya kita boleh masukkan satu temperature je dalam satu dalam satu equation ni lah. Okay, satu temperature. But for this one, we have last formula, okay, where we can relate. Kita boleh relate the two temperatures, the two different temperature, okay, at once. Masukkan dalam satu equation. Okay, alright. So this is the equation, the final formula that you have to memorize. Okay, at two temperatures. Okay, T1 and T2. So this is the formula. EA over R 1 over T2 is minus 1 over T1. Okay, alright. So this is after you have rearranged this one into this. Because ni operasi tolak. You kena begitu kan, darab silang dia tu kan. Okay, alright. So just be careful. Okay, the formula itself you have to be careful. Sebab apa? Okay, the other option would be, okay, jap. Okay, ln K1 over K2 and this, dia punya pair kalau sini K1, here should be T2. Kalau, okay, again, if up here is K1, that means the first T that you will be will be inserted into this formula will be T2 lah. Then minus the T1. Okay, alright. So K1 maksudnya rate constant dekat temperature 1. Okay, K1 maksudnya rate constant dekat temperature 1 lah. K2 maksudnya rate constant pada temperature yang kedua. Okay, so you have to be careful. You kena pairing tu kena betul. Kalau sini 1, sini 2. Kalau you nak buat the other way around, which is K2 dekat atas, K1 dekat bawah. Boleh, not a problem. It's just that you have to be careful bila dekat sini. So it should be 1T1 minus 1T. Okay, pairing dia dekat sini. Be careful guys, be careful. Okay. Alright. Okay, let's look at an example. Macam mana nak calculate, okay, using the formula just now. Okay, determination of rate constant K by using Arrhenius equation. The rate constant of a first order reaction is this at 298 Kelvin. Determine the rate constant at 350 K if the activation energy for the reaction is 50.2 kJ mole negative 1. Okay, mungkin nak pakai yang ada satu temperature je ke ataupun nak pakai yang this one? Okay, nak pakai this one. So, look at the question, read the question carefully. As you can see, we have two equations and then the rate constant is given for at 298 Kelvin and the question is asking for the rate constant at 350 Kelvin. So definitely kena pakai this formula. Okay, kena pakai this formula. So you masukkan the formula. Okay, again I would suggest everyone to write the formula first. Write the formula first before you substitute. Macam ni, macam apa yang kita ada dekat dalam jawapan ni kan. Dia terus substitute. Okay, alright. So I would suggest you to have the formula first. Ln K1 over K2 is equal to negative EA over R 1T2 minus 1T. Okay, alright. Because like I said last time, the more complicated the equation ataupun the formula is, the higher tendency for you to get mark for the formula. Lagi kompleks formula tu, tulis formula je boleh dapat markah. Okay, tapi kalau you tak buat, you skip this part and you directly insert ataupun substitute the equation with the values, you dah skip this part. Imagine kalau you salah substitute guys. Imagine kalau you salah substitute. So you will lose mark dekat sini. You tak dapat this one. You don't get this one because you did not write the formula. And in terms of substitution, it's also wrong. So you dapat markah kat mana? Final answer definitely wrong. So you tak ada markah langsung kat situ. At least kalau you buat the formula is correct. So you dapat 1. Maximum will be 1 lah. Normally we have a maximum 1. So at least you dapat 1 out of 3. See? Substitution ni bila banyak-banyak value macam ni, believe me, dengan unit lagi dengan apa, ada very high chance for you to miss out something. You miss out the point lah, 50.2 jadi 500 lah. Those kind of thing. Okay, alright. So try to minimize the error. So that would be my suggestion. Kalau siapa yang rasa you are confident enough ke apa, then go ahead lah, buat substitution terus. Okay, this is just my suggestion. Nak follow boleh, tak nak tak apa. Okay, and then you solve for it, you dapat the value. Okay, so you dapat the value, make sure ya, tekan calculator betul-betul, and K2 is 0.702 second negative 1. Okay, and then from the value itself pun, you boleh predict whether is this logic, is this value logical? Logic tak value ni? Cuba kita go through the question, okay? So you are calculating for 350k. Given to you is the key for 298. Kan kita dah tahu dia punya teori ataupun dia punya relationship when the temperature increases, okay, when the temperature increases, the rate constant will also increase. So that the rate constant will also increase. So from 298 increases to 350k. So we will predict that the rate constant, the value of rate constant should be higher than this one. That is our prediction. So let's check. Your value higher ke ataupun lower than that one just now? It's higher. Betul tak? Higher. So bila higher, okay lah. Oh, okay, nampak macam betul. Kalau you dapat lower than this value, you salah kira lah tu. Kira balik. Jangan biarkan, jangan just semata-mata calculate value. Bila you calculate value, you tekan calculator, you terus dapat, itu value yang you dapat, you terus tulis. How do you check? You kena come out dengan checking system. Okay, so that you make sure that ke barangkali yang you salah tu very low lah. And then one more thing you nak check, okay, bila you cancel out the unit kan, you should get the K2 should be S negative 1. Okay, let's check. They mention dekat sini kan, the rate constant of a first order reaction, guys. Of a first order reaction. Remember last time we have learned about the unit of rate constant for 0, first and second. Okay, so the first order reaction, the unit of rate constant should be time negative 1. Which is, see, S negative 1, which is the same as this one. See, tally, unit pun tally dengan the order of reaction, the order of the reaction this one. Okay, alright. Okay, alright. So another example, determination of activation. Sama juga, okay, this one has a rate constant. This is the formula, and this is the equation, and then this is the rate constant at 701 Kelvin, M negative 1, S negative 1, so tahu ni second order ni. Okay, kalau dah hafal unit of rate constant, boleh tahu dah straight away. Okay, and then this is the second rate constant at 895 Kelvin. So you are asked to find the activation energy in kJ per mole. Again, in kJ per mole. So you have two temperatures there. That means the most suitable equation to be used would be the one that has K1, K2, T1, T2. Okay, alright. So I do this one, and then you have to do the substitution and find out the final unit. Okay, make sure that you convert. Okay, you akan dapat in J first, and then baru you convert into KJ. Sebab the unit is in J dulu. Baru you convert into KJ. Okay, you akan dapat J dulu. Habis dah. Hello guys?
Hi, madam.
Still ada lagi ya? Tapi
Ada.
recording dah stop dah ni. Macam mana? Tak apalah, sambung je lah kan. Jangan. Okay, sambung je lah. Okay. So, maybe saya kena record lagi ke? No.
Dia tengah recording in progress kan?
Tak. Tadi dia kata dah saving. Tu saya, dah hilang ke? Apa yang berlaku ni? Okay, checkpoint 13 guys. Okay. Try to complete this checkpoint, but I don't think I can give you more than 3 minutes time, okay, for you to complete this checkpoint. Okay, try to solve for A, try to solve for A, B, try to solve for all lah, but try to do it fast, okay, because we need to proceed with the next subtopic. Okay, try. Cuba buat. I give you 3 minutes for this one, okay? Cuba buat. Nak make sure you ingat the formula, try tulis dekat tangan, mestilah guna tangan kan, try tulis, okay, hafal tak formula, and then try to insert the values, make sure to convert the temperature into Kelvin guys, okay, don't use directly, you have to convert the degree Celsius into Kelvin. Okay? Alright. Okay, let's go through the question. The conversion of cyclobutane to butene has a rate constant K equal to this value at 400 degrees Celsius. And then we have another K at 430 degrees Celsius. And as you can see, the value of K at 430 degrees Celsius is larger than the value of K at 400 degrees Celsius. Okay, alright, calculate the activation energy and then you have to provide your answer in kJ per mole. It means your first answer will be in J and then you convert into kJ. Okay, don't forget to change the degree Celsius into Kelvin. Okay guys, that is very, very important. Okay, need to be in Kelvin. And then B, determine the value of the pre-exponential factor for this reaction. Last but not least, if the temperature of the reaction is reduced to 350 degrees Celsius, calculate the rate constant K. For this time around, another new temperature is given to you. Okay, that means you can pair with any of these two. You can 350, you nak pair dengan 400, boleh. You nak 350, nak pair dengan 430, boleh, not a problem. Okay, so you should get the same answer lah. Okay, alright, so let's calculate for A, insert into the formula, and this should be your final value. Okay, alright, so how about pre-exponential factor, guys? Okay, so the thing about pre-exponential factor, we cannot use the K1, K2 is equal to 1 over T2, T1. Tak boleh guna that one because we don't have A, the pre-exponential factor in the formula. We don't have that in the formula. Okay, so we have to go back to the original Arrhenius equation. Is either using the exponential ataupun using the one after it has been ln. Kita dah ln kan, dia dah modify by adding ln. By adding ln. By adding ln, dia nak ng kan dia. Okay? So you need to use that one. So I will go for the apa nama, yang alternative form of Arrhenius equation. I will go for this one. Okay, alright. So ni pakai yang ini sebab kat situ je ada A. Kalau you pakai this one, you don't have A in this. Tak boleh nak kira A. Macam nak kira A? Tak boleh. So you have to use this one. One factor at a, I mean you have to choose one temperature lah. One temperature saja. Okay, alright. So you may choose this one, dia guna at 400 degrees Celsius. 673 is at 400 degree Celsius. Sebab 1.3 darab 10 kuasa negatif 6. Untuk siapa ni? This one at 400 degrees Celsius. Make sure you convert into Kelvin, okay guys? But can we, instead of using 400 degrees Celsius ataupun 673 Kelvin or this K, can we use the other K? Boleh tak guys, rasa-rasanya? Boleh tak kita guna the other K, at 430K, at 430 degrees Celsius, convert into Kelvin? Boleh tak guna yang itu instead of this one? What do you guys think?
Boleh.
Yang lain? Rasa boleh ke tak boleh? Ke nak kena pakai yang macam ni juga? Yang
Boleh.
sama? Boleh?
Bisa, boleh.
Bisa. Boleh? Okay? Boleh. So either you use this one or you use the 430 degrees Celsius ataupun 400 degrees Celsius, you should get the same value. Dah proven dah. Tadi student awal tadi dia dah calculate kan, memang dapat. Kalau you tak dapat, you salah kira. Okay? Right. Then last but not least, you want to compare with the 350 degrees Celsius one kan? You nak compare kan? Boleh you pair dengan this one, dia pair the 430 dengan, sorry, this is the 430. This is 350 degrees Celsius. 350 degrees Celsius. This one is for 430 degrees Celsius. You nak pair this one dengan this one? Boleh? You nak pair 350 degrees Celsius with 400 degrees Celsius? Pun boleh. Make sure sebab saya baca soalan tu, dia bagi dalam degree Celsius kan. Make sure you convert into Kelvin. The rest are all mathematical. Okay, guys? Okay. Alright, moving on.
Madam,
Ya, alamak ada catalyst.
boleh yang B tadi tu saya belum
Apa dia?
habis. Yang B saya belum habis salin.
Tengok kat video lah nanti saya upload video. Okay? Alright.
Okay.
Ada lagi the effect of catalyst. Okay, the effect of catalyst on reaction kinetics 1.6. This is this one will be the short one lah. Tak panjang tapi we still have to go through these slides. Okay, the effect of catalyst on reaction kinetics. Okay, make sure that you are able to name the type of catalyst and its example and then explain the effect of catalyst on the rate of reaction. Okay, so this is another factors that can affect the kinetic, the reaction kinetics. Okay, alright. So what is catalyst, guys? So a catalyst is a substance that changes the rate of chemical reaction without being used up. We have talked about this before in, remember last time we have factors affecting the reaction rates, kan? So in that slide, we also have defined the catalyst. What is catalyst? So catalyst is a substance that used or are added in the reaction, okay, to increase the rate of chemical reaction without being used up. Maksudnya at the beginning kita masukkan bersama reactant and then at the end it will still be there. It will not be used up. Okay, alright. So we have two types, homogeneous and heterogeneous. So homogeneous, the word homo here means the catalyst exists in the same phase as the reactant. The same phase as the reactant, guys, not for all the substance in the reaction. Okay, our concern is more on the reactant. That means okay, look at the reaction that we have here, decomposition of H2O2. Okay, so Ki is our catalyst. So Ki is in aqueous phase. So when we say that Ki is the homogeneous catalyst for this reaction is because of the phase is the same as the reactant. But is it the same as the product? No, it's not the same. Bukan, homogeneous is defined based on the phase of the reactant, not based on the phase of the product. Okay, so that's the reason why we're subject to this reaction. Okay, Ki is a homogeneous catalyst used in this reaction. Whereas heterogeneous pula exists in different phase as the reactant. Okay, look at here. So iron is the catalyst used in this reaction, and it is a heterogeneous catalyst because why? Dia punya phase is different than the phase of the reactant. It is in solid phase compared to reactants are all in gas phase. Okay, alright. So what is the purpose of having catalyst? Okay, so how does catalyst act? Macam mana catalyst tu berfungsi? Okay, ya kita tahu it increase the rate of reaction, but how? Bagaimana? Okay, alright. So imagine, this is the, yeah. Alright, so this is the normal profile energy diagram. Okay, where we have a very high EA there. Okay, so the EA need to overcome. So that one is without catalyst. When we add catalyst, what happens is that the EA is now reduced, guys. The EA is now reduced. See, kalau EA reduced, so initially ataupun originally, this is how high the EA. After the catalyst is added, it is now reduced. Bila EA to reduce, more molecule will have sufficient energy to overcome the EA. EA dah rendah sekarang. Okay, EA dah rendah. Okay, yang boleh rendahkan EA adalah catalyst. Catalyst only. temperature or whatsoever, those cannot reduce the EE. Only catalyst has the ability to reduce the EE. Okay, alright. So this is how it looks like. The catalyst provide alternative pathway sebenarnya, okay, by lowering the activation energy. Dia menyediakan satu jalan alternatif untuk produce produk. Ada satu cara lain, iaitu dengan lebih mudah, okay, by lowering the activation energy. Okay, alright. If we were to represent it, okay, we have few pathway reaction lah. This is one pathway reaction. One pathway means we have reactant, directly it will produce product. Okay, alright. So when we add catalyst, it will also it does not alter the reaction by having more reaction. Okay, when the catalyst is added, you still akan from reactant producing product. Okay, ada catalyst yang begitu perangai dia. Maksudnya dia punya cara dia bertindak is just by reducing the EE macam ni. Tapi still from the reactant producing product. Another way of catalyst